As it says on my notes, right, so testing unfriendly code, a crash course in stunt programming. Now, what it says on my notes, which have been briefly edited, is this was a talk originally given at work. It's also a talk given at in Helsinki last year, and I basically hadn't looked at it until this morning or last night again and went, I know that some details have been removed to protect the guilty, and our code is beautiful. Anyway, sadly, we're not hiring this week, but we will be soon. Relates to a merger where our company, the year ends don't line up, so we're having a special mini 3-month year to line up with them, which means everyone's budgets are just delally. So that's a bit of a long slang word. Anyway, we will be soon. When the things line up, we'll know what we're doing. And we have 20 years of profitable legacy code. And that's a talk about, this is a talk about that. Timer is out as well. 10 hours and 2 minutes. I don't think that's how long I've taken. So the company, as I think Lisa said Monday yesterday anyway, was founded in 2001, originally Give and Gain, a charitable giving company that survives. The code was forked about 2 years later to make a payments platform for rental payments. The code has evolved continuously for 23 years, and so our older code is most certainly battle tested, but not regression tested. So me. I am, or you might claim I'm a core Perl hacker. Well, I'm just resting, darling. I've been working for over 20 years. I have many employers. Not all of them went bust. Been to a lot of conferences. I'm mostly self-taught at programming, and I had to edit this. I've now been at PaperOp for more than 2 years. It didn't used to say that. And what are we trying to achieve here? What's this talk about? So what is testing about? Testing is about getting to the place of interest and then trying out the different code paths there somehow. I realize I need to rearrange the speaker notes, but I'm going to live without that. That's why I keep looking around. And so the question about the somehow is, can we call it directly? Or, if not, how close can we get to that place where we're trying to test? And it's all about forcing the control flow of your code to get there. And if all the obvious and sensible ways fail to get you to the place you need to test, cheat. So this is a talk about perverting control flow. For testing legacy code. The disclaimers on this. Don't do this at home, or in production, or in new code, because you are creating technical debt, and you need to throw it away soon. And we did this and ignored that advice, and got in a very big mess, which is what the next talk is about, how to fix the outcome of this talk. So, I'm talking about a particular script to protect the everything. I'm calling it batch script. It exists. It's kind of important because all the money in the system flows through this script. If it falls over, money stops moving. It needs tests. I said it's a script. It's not a module. It's a script. It was never written with testing in mind. I said all the money flows through this thing. Mistakes are expensive, so not fun and not profit. Oops, I should have mentioned that more on the previous slide. I did obliterate the name here, but the point about the name was it was named for South Africa. It's named after the bank's product in South Africa, but then it also gets reused for the UK and everywhere else. So despite having a South African brand name in its name, it's used everywhere. That becomes relevant later. There are a directory of scripts. I think there are 96 in it, and not many of them have tests. And there are plenty of other things we had to test at work that are similarly hard to test. So, your conventional approach to testing is, first of all, you refactor it to make it easier to test. Then you add tests to it. Yeah, cool. But how do I test that the refactoring was safe? Can we test the code without changing a byte? I mean, the other approach of first refactor it, there was a colleague at a former employer, and don't worry, that he left in 2018, so no one here who might still work at that company needs to worry about this. But he went, hey, tests are important. Correct. This needs tests. Correct. I have refactored it so that it is easy to create tests for it. Dude, you just did the most dangerous thing without any test coverage. So we're trying to create the test coverage to let us get that first refactoring done. Yeah, remember, remove glasses before banging head on desk. I'm still nervous. I think I'm on time though. So yeah, there's a lot of code on this. That's the top level of this script. Don't stress too much right now. I'm going to pick apart the important pieces. I did realize in running through this, related to our talk on Monday, I'm going to leave the microphone, aren't I? That this is the only slide where you can see 6 and 7. So 6 is Saturday. If it's Saturday and it's in these times, this is banking hours. This is hard-coded to South Africa, despite the fact that the rest, well, not necessarily the rest of the world, the other 3 places in the world we currently care about do not. So yet again, in trying to write test this script, I found a piece of silly in it that should have been done differently. The other bit is that variable is renamed. Inside banking hours does not matter about banking hours. It's when it actually sends out alerts. So why is it hard-coded to send alerts? Legacy, makes money. Anyway, this is what I've got. I've got this piece of logic that says, if today is Saturday and it's within these hours, then do something. Just actually send an alert. Otherwise, if it's not Sunday, it must be a weekday, a full-on weekday, and it's between these hours, send out an alert. And I want to write tests for lots of things like this. So let's pick the first part at the top. Current time is a datetime object set up as now. And the block I'm trying to get to is if the hour is 5 and 15, we are inside banking hours. But what I want to do is write a regression test that passes 24 hours of the day. And I want to test in that if. And I want to test outside that if, the else block, which may or may not exist. Coverage talk yesterday. This is a different script from the talk on Monday, but we've got the same issue. I want to write a test that runs 7 days a week, bank holiday or not. So how am I going to test this? Well, this is fairly easy. We get to the slightly crunkier stuff later. I want to override date time now. Rather than returning me the current time, I want it to lie. Alternative fact. I want it to give an alternative fact that it's within those hours, outside those hours, all that stuff. That's relatively easy. Override date time now. Sorry, that's actually what I just said. I want to test inside that range. I want to test outside that range. So for a module, that is easy. Datetime is a module, it is easy. You make sure you load the module pretty early. You override that method to the one you want, but lies. And you do that in good time, and when something comes to call it, it gets your alternative fact. Yes, today is definitely Friday. And so on. That works for a module, right? This is a script. Yeah, time's okay. So, we have a necessary interlude where I digress. This is not quite true. A digression about when things happen. And there's about to be a slide with a lot of code on it, which I will go through step by step. Do not be scared. But I want to talk about compilation and runtime. Because you might think that Perl is an interpreter, but what it actually does is it takes your program, your script or your module, it compiles it to a tree of ops, it finishes that, and then it runs those. But it can do that in a nested way. That's what we're getting to. So it always has an idea of I compiled it, and then I run it. So, I am talking about my script called when. My script calls the hello subroutine, which came from somewhere. And, it calls hello, it uses a module, and the subroutine announces I am subroutine hello. And it pulls in a module with use. And the use module is here. And am I on? Yeah, good. Oh, I'm loud. And here's my module, and it has a subroutine that is run, that it doesn't export, but it is called, that's right, and it has some print statements at the top level. So what happens? Compiling. Use strict. Compile the call to hello. Reach the use statement. This is special. I'll be clearer soon. Use statement immediately goes over here. Pull this thing in. Compile this. Compile this call. Compile this print statement. Compile this module. Sorry, this subroutine. Told you I'm stressed. Compile this print statement. Get to there. Finish. Run this. That's all later. That's all run. Oh, a thing to run right now. Print. Module top level code. Phew, it does say that. And then carry on. That's all done. We've got our things defined. Carry on. Compile this. Remember it. Compile the call to that. Right. Compile here has finished. Runtime. Run through. Execute that call. Hello. Print subroutine hello. That's that. Execute that. Print modular subroutine called. There. Use is immediate. As soon as the compilation of this place gets here and goes use, it goes, stop. Placeholder, thing. Like compile, run, back. Use is immediate. Okay. Require. If I change that use to require, which all the highlighted bits are in bold and orange, so I hope everyone can. My only problem is the back of the room is a long way away. If I change that to require, drink tea. Start the same way. Compile, hello, compile, require. Require doesn't happen right now. Only use is immediate. For require, it says, oh, I remember I must do this at runtime. That. Okay, execution time. Execute this all to hello. Or hello. Subroutine hello is called first. Then it reaches the require. Execute the require. This triggers the, oh yeah. Compile all this, compile all this, compile all of this. Run this. Oh, this is the thing I can run. Module top level code. Finished. Compile. Sorry, we're on running. Forgot that. Sorry. Run. Print some stuff. So the order of these differs. Require is runtime. Require happens when that is reached. I shall go back to the use slide. Watch these change. So for use, module top level code runs immediately because this triggers a compile action. Why am I drinking tea, not espresso? I'm not sure. I heard stories about quadruple espressos.
Good morning.
Morning.
Security and safety police.
What have I done wrong?
No.
Oh, gee, yes, thank you.
Did everything right.
Well, I didn't set up properly. It's given I'm the assistant AV. It's obviously my fault. Thank you. Yeah, I had it tangled around the monitor cable, which is not going to end well. So all those uses are begin blocks. And so a begin block is a thing that happens right away. So here is a deliberately more funky script, but it's actually, I'll go through it. So we start at the beginning compiling. We reach an end block. End block says, remember this, do this at the end of the program. That will print that somewhere at the end. Compile. Oh, compile this. Remember this, do this at the end of the program. Compile. Compile that print statement. Begin block. Reach there, the close bracket, and it goes, oh, finish that, must run it. First begin block. Compile. Finish that. Second begin block. Runs. This is now compiled. Yeah, sure, there was some running of code as well. That's what begin blocks are about. That's what the whole of this talk is about, why I'm doing this. Runtime. Comes through. Those are all compiled, those compiled. Something runs. Prints top level. Reaches the end. End blocks stack in reverse. I'm mentioning this. There's not much more to... don't need them for the rest of this talk, but they're there. So we saw that second, that's at the top of the stack, that pops off and fires, that pops off and fires. So that's my ordering. A begin block, end block with a sausage in the middle. Right. Ah, yeah, as my notes thing says, string eval happens much later, don't worry about that, and other phases exist. That's the term coined by the language formerly known as Perl 6, and it has even more. So, I'm going to take this code and add a die there. Die horribly. Whoa, same code, same thing. Compile, 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 stack and end, compile that, compile, closes. Cool, do stuff, print. Compile, 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 closes. Do stuff, print. Chug, compilation finished. Execution, stuff, die horribly. Program ends. This is not reached. End block still run in reverse. I'm explaining this. It's not necessary to the rest of the talk, but it was explaining because I was on the way. I realise. I lose track. What's my timing? I think that's okay. Where am I going? Here. 2 more of these digressions, I think. Begin blocks, nest. In this one, it's not. I could have made a convoluted one. Anyway, so compile, compile, compile. Compile the print 0. Compile the begin. Compile that. Compile. Oh, new begin block. When we reach here, we finished this begin block. So we print 3. When we reach here, we finished this begin block. We print 2. When we reached here, we finish this begin block. We print 1 because we've run its code. All this has already happened and been forgotten and actually thrown away. And finally, that's compilation done. We've already run a bunch of code. And now it's actual real runtime, and we just print that and compilation. Begin nests. That's the important thing from this slide, and that's how the rest of this talk hangs together. So, that was the end of the digression. Go back to my script. I can see the next slide. It helps. The question is, and I'm not tall enough, can I inject code here? I got my script. It's going to print begin block, top level, end, end. I want to cheat on it by somehow running code there. Because, if I can run code there, anything that runs immediately, I can hook in some way to run a bit later as well. I can make some sort of deferred action. So, there's -m on the command line. That thing in bright orange bold orange over there. It's like putting a use statement before the first line of your script. This is evil and effective. What this means is it goes first. But it goes first in your script. So, by doing this, I have injected code without changing my script, which was the goal of this. So, how does all the execution work? This is my override package, override.pm. So, my script, the -1 line, actually I have flipped back to the previous slide. It's the first time I have to do that. Runs at that point in orange with a whatever. Module compiles an end block, compiles a print statement, compiles a begin statement within the module, reaches there. Print, module begin block ends. Compilation of module finishes. Runtime of module continues. Module top level code. Second thing we run. Then we got back to my script that said begin, top level, end, end. The module end block goes absolutely last because it was the first end scene. This is a push down stack. Things come back the other way. Don't worry about the end blocks. But anyway, I can inject code into the script without changing it. I think we're mostly there. Slide 20 of 36. Well, they're not. But I think the timing is good. So, to inject code, it's the overview. How do I inject overrides into a script? Scripts compile and run. So to hijack it, I put it in a module. I add that to the command line, and voila, I've done it. So there is my basic technique for, here is a critical script I need to test and refactor. How am I going to change what it does without touching it? Put it in a module, do things. And what followed were things we did. And the fun bit I realized looking through this talk is they feature in the next talk immediately as things we did and regretted. So, don't do, in my module, I could do many things that turn out to be great. Right, so, we have legacy SMS library, which will feature in the next talk as well. It's so old, it's a require statement. So it works, as I said. So you require it. The way require works is it won't load the same thing twice. There's a caveat on that later with a good explanation of, you know, the trap that some of you already know. So I require it nice and early, so I have loaded it. Don't want it to load a second time. And I load it really early, and then I tell it, redefine the SMS message sender thing. And instead of sending a message, just print it to standard out. I am sending an SMS to someone about a thing. So when the script sends an SMS by calling the SMS library, instead of actually sending an SMS and trying to get it to my phone or someone else's phone, it just prints on standard out. And my invoking test script is checking standard out and making sure that's been called. That's the icing on the cake. The first version is it doesn't annoy someone. So yeah, I can override calls to libraries required in the script, which otherwise I couldn't do because that require happens late. We have logging. I can trap the logging. Yeah, mock objects. If it quacks like a duck, it walks like a duck, it is a duck. This will feature in the next talk as well. So fairly standard thing. You can use a mock object. You create a mock object. This slide is old. You can set the ISA on the mock object to say I'm a logger. We forgot that. That's on the later slide. And I iterate around and I say I want an info, a warn, an error, and a fatal method, and I'm going to create those methods, and they're going to print to the screen. I logged at this level, or shouty that message. And there's logging at trace and debug level, and I don't want to see those, so I just bodge them away with the cheapest thing, which is say, oh, they return true, but do nothing. And then for the method, the code, the regular code calls to get me the logger, I say override it, return my mocked logger. So we can actually, among other things, apart from just stopping the logging going somewhere, we can test the control flow. Because some of this code is a bit, and the only way to know where you've got to is to look at the log output to see what happened. So, fairly basic mock object. I'm worried everyone's asleep, including me. Ah, there was a laugh. Someone arrived. Hey, we get back to this. I remember this from earlier slide. I hope you do as well. I want to test this. Is it a weekday? I can just mock a daytime object. But what I can do is I can say the alternative fact of time, well, the time I want to pretend you. Believe me, it's Saturday. I put it in an environment variable. And I have the same piece of code overriding with an environment variable, and the invoking test script says, it's Saturday, it's Sunday, it's Tuesday. And then there's a bit of a god-awful mix. I set the environment variable in my driving test script, and then I call the victim. Yeah, okay, I picked choice words. I call the victim like this. The thing I'm testing. Oh, there's a note on the slides. Oh, this, yes. Like what Lee said, datetime objects are mutable, hence the need for a clone. Because otherwise, I would have created one object, returned that object, my calling code would do some arithmetic on the object, change its value, and I'd move now. And there might be places in the script where now is called twice, and both of them need to return, well, actually the same fixed time in history. But yeah, it is annoying, arguably design failure of the datetime classes that they are mutable. They really should be immutable, and things should return a new object. That would have some efficiency. Sorry, yeah, but this was trap. Avoid trap. Don't completely cargo clone everywhere, but be aware that you can be caught out. Because you're overriding a method that always returns a new object. What the easy mistake is to return the same object, and then the same object gets into 3 places, and that isn't really testing the right thing. Aha. So we take this one further. That's overriding with an environment variable. Always. Now it's always going to be overridden. What happens, you know, I said I've got some code in there that's for the UK. and I want to cheat. I want to run this thing, and I want to test like I'm in the UK, and then I want to run the same, run it a second time and test the South African code paths. And usually it's reading all of this from a JSON config on disk, and I don't have a good way to change that JSON config. So the payload of what I'm really trying to do is, if this environment variable fake instance as is set, if we fake that, if we fake that, and we are making a specific lookup on this key, and sometimes it's JSON pointer syntax, sometimes it's slash instance, and sometimes it's just instance without the slash, then return my alternative fact, like UK always. Inside my mock object for get, which I set up. So I mock the configuration system, and I have a... What am I doing? I'm making sense. I get the original configuration object. I make a mock that lies, overrides it. As a singleton, yeah, this makes sense. And then for this case of a particular key, I return my lie. And for everything else, I delegate to the original. Sorry, I told you I hadn't read this for ages. I'm just not sure actually whether I needed config and original, because that's a singleton. That's suddenly going through my head. I told you I'm not awake. I should just lie and pretend these are perfect. It works. That was the important bit. So this is how I override one key without having all of this code balloon up to be able to return 100 different keys faked correctly. All my environment variable having to create the entire config with one lie put in 99 truths. I can conditionally do this key gets a different value and everything else delegates to the original. So yeah, mock objects can take you back to the original. I've just overridden the value for instance and all the rest are unchanged. I think my timing is still good. I'm astounded by this. Next question was, can we fake the database? Because one of the bits of that thing is it a public holiday? And, oh, it's our friend bank holidays again. Select from the bank holidays table where it's the current date. Now, I want to test when this is true. I want to test when this is false. And I can't easily control the current date function. I can't tell the database to make alternative facts. Certainly not easily. There are probably expensive ways to do it. Well, yeah, but what I can do is control that table. The bank holidays table. What? Database fixtures are your friends. You start with an empty bank holiday table. You don't have the truth in there. There are no bank holidays. So today is not a bank holiday. Even if, like, the US, it's whatever, June the 19th. I think that's now the bank holiday, Juneteenth. Even testing the code for the US on June the 19th will not be a bank holiday, despite the fact it is a bank holiday. If you're crazy enough to run the tests on Christmas Day, they will pass because they think it isn't a bank holiday. Then what do I do? In my tests, after having run the it's not a bank holiday set tests, I go, hey, let's create some bank holidays. I declare today and tomorrow are bank holidays. I'm trying to be paranoid here. If the test is running at almost midnight and rolls over, today and tomorrow, or maybe it's now tomorrow and it's new today and yesterday, whatever, there are two bank holidays. And now when we go, is it a bank holiday? Yes, because I just made it one. Yeah, observe my paranoia. I made sure there were two rows inserted. Do this. Update that touches 0 rows is still success and won't error, even with Ray's error. And 10, cool. I think I have 9 slides and one of those is the bonus. It's not much of a bonus and it's not a rickroll. Test them, because this saves a lot of time just getting into the sort of obsessive compulsive thing of testing it. Did I get 2 rows back? Test your updates and test scripts. Test inserts and updates, because it will save you time at some point. You're not going to spend 3 hours. Why is this not working? And it turns out there's a really subtle error in a where clause or something in your test script. And you just didn't notice because it carried on regardless and the next test failed. And you think of everything else first and not that. Basically, it doesn't matter to have another if statement. Tests are cheap. Yeah. Also, there was a comment in here that I do have subroutines in my test scripts when I reuse codes, but not usually otherwise. and I am trying really hard to make my diagnostics unique so that this string only appears once in the entire test script, so that if I just see that string, I know what line number I can find the line with it, not have to dig backwards in the line number. Because if it's OK1, OK2, OK3, OK4 with no help, then you have to count through both. So the final bit. What do we get to? I want to test this script. I thought we had to. It defines a hello world statement. Sorry, this is not localized. It's hello world. Hello world in the script. So -m on the command line happens when? It happens here. At the begin time, there. All that has run before the script even compiles. So my first naive idea of overriding this script, well, obviously I shall make an override library that redefines hello to print something more meaningful, and it would look like this. I put in a module, I'd override main hello to say the world is not enough, and I left the errors in. That's the point. My code override was run at begin time. It got there first. It defined that. Begin time came and went. The script runs, and it now defines, well, redefines, and subroutine hello redefined in the script, line 5, and it still says hello world. The subroutine came second, sorry, the script came second at defining the subroutine. It won, and my thing didn't land. Bother. How do I fix this? It runs at begin time. So there are other phases, check and init, and they're both a bit annoying and sort of wrong because they weren't thought through. Check runs effectively at this point. Compile, 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 compile. End of main program compilation, all check blocks run. Start of main program runtime, all init blocks run. It is that if you load a module dynamically later with an init block, you'll get a warning of it's too late to do init blocks. They should be done the way that Raku does them in terms of per module. But Malcolm Beatty, implementing these 20-something years ago, didn't think about it in terms of modules. Anyway, we can hijack this. We can hijack the wrongness to our benefit. We have a hook in an init block that will run here. So as this script compiles, it goes stuff, compile hello, compile the call to hello, run my init block. And I put my init block in a module here. So my new module looks like this and hides this in an init block. Module loads, compiles, runs. Run, like those end blocks earlier, stacks an init block saying, do this at init time. And I left the warnings on. This time, the redefinition happens in my override library, my improved override library. So my code ran second, well, last. My code wins and redefines. And I hadn't seen anyone do this before, using an init block to override subroutines in the main program. And it prints the world is mine, which I think is moderately appropriate. Nearly there. Everyone's still asleep. The caveat earlier was require. Require is a bit of a trap. The way it caches things is based on the name you give it, not the name it found it on disk. So if I write require.library, and then with a full path name or a relative path, whatever, it's different. And my script, I'm requiring, it does load data dump and spray the core out. Well, this one, code line 6, it sprays the core out as main package there. This one is cached. The cache hits because that string is exactly how it's cached. This, I'm getting 5. Sweet. This one has a different path name, so the cache key is different, so it loads the thing again. And this, if I had subroutine definitions in there, they'd all get redefined. I'd get double load warnings. And I found this while trying to override stuff, that initially it was being required from a relative path, and then some code elsewhere later cleaned that up to an absolute path, and then I required seemingly the same thing, and it had a different path to get to the same disk file, and it loaded. I loaded and overrode it. It got a second go. It won. So in all of our test scripts, we're cleaning these things up to absolute paths really early. So, if I got this right, this is the wind-up slide, first one of 2. We clean up to absolute paths. We override module. Our technique is to things like direct type glob assignments, mock objects and mock modules, as I showed. There's another thing called mock quick that also lets you override stuff. And ultimately, you can also override core global, which we get to in the next talk, which gets to the time when you override it. But that's a really big hammer. It's like if you override core global open, you override every open call in the whole thing. And that gets complicated. So, for work, I could say, look at this file, but I can't here. But your override should be minimally specific. We had this thing, it seemed a bad idea to create a library. We're always dithering forwards and backwards between should I create a library or not. I tend to take the view that the second time you copy it and the third time you go, oh yeah, I need this more, don't I? Our goal, I wrote this on the slide and then we wrote the whole next talk by ignoring this. Our goal is to eliminate it, not ossify it. Ossify is turn to bone. It's a brilliant word in English. Bones are fragile, rocks are not. So what we should have done is refactor soon to pay off technical debt. Months later we didn't, and then another talk comes in very soon. So that is the end of this talk. I would propose to run straight into the next talk, but I feel I really need a coffee. So, zwei Minuten. Oh, question. I have to do the question. I have Ruby.
Think about ink hooks.
Oh, ink hooks. You asked this before. I completely forgot about ink hooks. We never used them. It didn't matter for what we were doing. Ink hooks let you override what files come back from ink. Yeah, we could have done that. I didn't think of it, and I still hadn't. Oh, gee. What?
You can insert the subroutine into the ink, which when it sees not a path, but a reference to a subroutine, and require or use are trying to include a module, it will run into the subroutine, and subroutine gets all parameters and can decide what to return. It can even return a string. So you can mock perfectly.
You can mock perfectly. Line for, yeah. That wasn't as. I mean, I should know about these things. Did I say I was a core hacker? I implemented most of that, at least the more elegant parts. Oh, the doing it as a method call, that one. Yeah, ink gets forced to a method in main. You have to be very careful. Yes, you can do it and do that, but if I want to override a particular thing, I'd have to read in the entire file, parse it, and then take out the section I wanted to lie about that. It didn't seem as easy as.
No, you can still do multi-patching on subroutines. It's just for the timing when you do multi-patching.
Not on main, I think. Anyway, I want to show you how I eliminate all this crap, which is probably more important. After a coffee, which I'm getting into negative time on. Aristotle beat Jude. Aristotle?
So as far as inputs are concerned, I was thinking of Perl will require basically just a book, just to say, to check if it's a relative path. But the link book is probably better.
So Aristotle.
If it's a relative path and throw an exception if it is, so that you can find it, traces and code that.
I don't know if that came out in the recording. Aristotle had suggested use a core global require hook to error if it's not an absolute path, and then find those things. That's a sort of idea. I just brute forced it by cleaning it up all earlier. Yeah, you could do that, but as you'll see in the next slide about overriding core global open, I've been rated 1.
Yeah. Daytime movement.
What?
Daytime movement.
Oh yeah, Daytime Moonpig. Go look at the Moonpig stuff by Dominus and Ricardo, and I can't say much more than that. It's a really great article. I think Suram wants me to carry on. You want me to get a coffee? Right. Drop the mic, get a coffee. I'm going to get a coffee. Technically, you can too, but I'm going to start when I get a coffee.